Hey, my name is Adianas, and this is my assignment 2 for the graphics class. So for question 1, I have this working just fine. There's the triangles that have the gradation from the peaks to the center, and the way I did this is just assign those colors to the vertices. So the two center triangles are going to be yellow, and the outer peaks are going to be their respective colors, and the interpolation between those colors and the pixel shader happens, so we get that gradation from blue to yellow, green to yellow, etc. And that one was pretty simple. For question 2, that was the individual colors without gradation, and the way I did this was instead of having them share vertices, they share the same position but they're different vertices, so I added, I think it was like 4 more vertices than what I had normally, because we don't want to reuse those same ones since they're going to interpolate between the colors. So you see here these 4 vertices shared among the 2 in the center that are yellow, and then each triangle has its own 3 vertices with the respective colors, so that way they technically still interpolate but between the same color, so we just see the solid color and not the gradient. And that one was pretty simple too. For question 3, this one was just flipping the struct to be color position instead of position color. So we'll see this looks the exact same, but if we go into the DX app H, we'll see that the struct has flipped, so it's color and then position. If we go into the source, we'll see that the layout has changed, so now it's color and then position. And this is the most important part, because we had to swap the layout, but also indicate where the data starts. So the color will start at the first byte at 0, and the position will be the one that's appended and aligned to the memory. So we were talking about in class how the color is usually 40 bytes over or so, and the position starts at the first byte. When we swapped this around, we had to swap the starting positions in memory, so the color starts at 0, and the position is the one that's aligned. And once that was changed, we got the effect that we were hoping for, and everything works the exact same way. And of course, we had to swap the position of these in the struct, so it's color before a vector. Indices stayed the same, and yeah, it's pretty much it for question 3. For question 4, I had more of a tough time. I was only able to get a single color for the star, but it is using the array of colors that I chose. So you'll see here it's either yellow, or if I switch this to 1, it's red. And of course what this is really just doing is assigning each pixel's color to either the 0th position in the array or the first position. If we go here, I created the constant buffer, and I also created the vertex struct and the constant buffer struct. So if we scroll down here, we'll see that the first position is indeed yellow and the second is indeed red, and these are what's controlling the colors here. So again, the 0th position is going to be yellow. I can change this to say blue. So the changes are being reflected, it's just that I don't have a way to get the second parameter of the struct, which is the int color, to be what's actually changing the index here in color buffer. And this is just happening in the pixel shader when it should probably be here in the vertex shader, affecting the color, changing it from the vertex, and then the color is being returned here. But I wasn't able to figure out how to get that index to reflect the changes, so I just left it at that. As for the further work, you asked the difference between a constant buffer and a shader constant, and what I got out of it was that the shader constant is the actual data that is affected by the shader model and can be grouped up onto a buffer, so either a constant buffer or a texture buffer, and that data is optimized accordingly. And it looks like constant buffers are more efficient for supplying that information to the pipeline. So we use the constant buffer to dynamically change color, and we were able to use that, like in example for question 4, we would have used that to change the colors dynamically based on the data in the struct. So the shader constant's the actual data that we can group together and put onto the buffer. That's loaded into the buffer and then into the pipeline. And the constant buffer is the one that streams that output. And that's pretty much what I got out of that information. And I think that's about it. Oh, right, the second further work question, sorry. The second question for further work was the demo. So I'll run this here. Inputted your math here and we get the result that we don't want, as opposed to the result of all the pixels fading out to white. And the reason this is happening this way is because we're not actually affecting the pixels surrounding the triangle. We can't actually alter those because we're solely within the triangle. Because the shader that's on the triangle is only affecting each pixel. We're not affecting the vertices and we're not affecting the surrounding area. We're literally changing the color of each pixel. So every pixel that exists on this triangle, only those can be changed. So we get the same effects within the center up until we reach the edge of the triangle. And that's when we don't go out because the pixels of the triangle don't exist out of this area. If we were able to correct this, then we could get that effect around in a circle, just how you had the picture. But since it's contained to the triangle's pixels, and this is the only effect that we can get. And that's what I got out of it for question 2. And that's pretty much it. So thank you for watching. Bye.